What's up, people? Welcome to today's session. How are my people doing? How are you guys? I hope all of you guys are taking care of yourself, staying safe. The pandemic is still not done, even though the lockdowns are done. It is still not over, so make sure you stay safe, people. So, welcome to another session of Light. As you guys know, we are doing this particular chapter. We have already completed 4 sessions of this chapter. This year is going to be the 5th one, where we are going to be talking about a very small topic called as magnification. So today's topic is all about magnification of spherical mirrors, and once again a very warm welcome to you people. Now before I get started with the topic and all of that, I would like to start off this session with a quote, a simple quote. But this is one quote that I believe is very true. The quote is this: be happy, always wear a smile no matter what the situation is. Not because life gives you a lot of reason to smile, that's not always the case, but because your smile could be the reason that could make another person smile. And that is something that I truly believe in, guys. No matter what you guys are going through, and I know that you guys are going through a lot. Some of you guys might be running to try away or trying to run away from that problems. Some of you guys are facing it like superheroes. Some of you guys might avoid the situation that is there. No matter what is going on in your life, guys, remember that tough times don't last, but tough people do. And remember that you guys are tough. You guys are the best of the best. There's no one in the world that can replace you. So whatever the problem that you guys are facing right now, that is the one that is going to help you shape to be the man or the women that you're going to be in the future. All right, so always smile. All right, so anyways, guys, my name is Anoop and I'm a master teacher of physics here at Vedantu. I've been teaching for past 5 years now. I've taught and mentored thousands of kids, even 10,000 plus kids all over the country. I've helped several of my students score 95% as well. So that's a little bit about me. Now more about us. We'll get to know each other as the days go by. If you are here for the very first time, you guys might not know me. So as we go ahead, we will be getting to know each other. One each day will reveal a little bit of secret of my life. But yeah, yes, today's secret is that even I always keep smiling no matter what is going on around me. So I would urge you guys also to smile, because smile is infectious, people. Whatever you do, it will affect other people also. So spread some positivity, you know. All right, so anyways, guys, this is the 5th session. Like I was telling you guys, we are going to talk about magnification of spherical mirrors today. Now we have a lot of topics to cover, but yes, guys, if you are also interested in the updates, that you want to get all the updates of Vedantu 9th and 10th English channel, you guys can also enroll into the Telegram group. The link is right there, https://t.me/Vedantu 9th and 10th English. So if you enroll into this channel, guys, this Telegram channel, you guys can get all of the latest updates. You can communicate with your teachers. You can also get all of the regular schedules of every session that is going to happen on that particular day. So you guys can take a look at this Telegram channel as well, which is going to help you guys to stay in touch with all of us, right? So yes, guys, I also have the update of your pro exclusive micro courses, where I will be teaching you people the micro course over here. So on the Vedantu platform, that is, I'll talk more about this pro exclusive course later on. But yes, guys, if you enroll into Vedantu's pro subscription courses, you guys can also take up these courses for free as well. So these are the 2 topics that we are covering at this point of time. Be a pro in lens, bro. And then we have master electricity like never before. These are the 2 topics that we are going to be covering, right? So anyways, guys, I had also asked you a homework question in the last session. This was basically the question. This was the topic: sign convention of mirrors and mirror formula. We have already seen that in the previous session. So I had asked you a homework question. This was the question basically: all distances above the principal axis is dash. The answer: is positive, people. Anything below the principal axis is taken as negative. Anything above the principal axis is taken as positive. So here it's going to be positive. Right, guys? So that's it. Let's get into magnification. Now, guys, a couple of things I would like to recap is that, okay, we'll just skip through all of this because I'll show you the questions towards the end. The couple of things that I would like to recap you guys is this. See, guys, spherical mirror, as I told you in the start of the session, that it's something that we use in a lot of different places. It is used in your shaving mirrors. Spherical mirrors are used in the side view mirrors of your car. Spherical mirrors are used in your dentistry as well. So a lot of different places we use spherical mirrors, keeping in mind that the purpose they serve is a little different. Otherwise you could have used a plain mirror, but we don't always use a plain mirror because there are a few things, or there are few applications in life where you might need a different type of image. And one of those special features of the image formed by a spherical mirror is magnification. Now, what is magnification? Is not just to magnify something. If I have to talk about in terms of how do you define it in terms of physics, magnification is nothing but the ratio of the image size to the object size. What is the ratio between the image size and the object size? That is what is magnification. It is not just to magnify something like you have your magnifying glass. It does not work like that. It is not just that. Magnification in physics means it is nothing but the ratio of the comparison between the object size and the image size. So the question is this, guys: what is the reason for magnification, especially in spherical mirrors? Because in plain mirrors, people, the image size and the object size is going to be what? Is going to be the exact same. And in the case of concave and convex mirrors, magnification is a lot different. Now, here's the thing, guys. The major reason why this happens is because when the object is kept at a certain distance from the mirror, the kind of image formed is different. Right? For example, when the object is kept between, let's say, infinity and C, the image is going to be formed beyond, or between C and F. So yeah, again, as you bring it closer and closer, as you bring the object closer and closer to the mirror, the image size is going to get bigger and bigger. It's going to get bigger and bigger, and the image is going to be formed further and further away from the mirror as well. So you have to understand, guys, depending on where the object is kept, sometimes you might get a bigger image, sometimes you might get a smaller image. Now that is about your concave mirrors. But in convex mirror, guys, no matter where you keep the object, you will always get a diminished image. Now that you've understood that, like what is the reason for it? Because again, when you draw the ray diagrams, we've already seen that when these, if I take two standard incident rays, the way that they intersect is going to be different wherever the object is kept. So because of that, the type of image or the properties of the image formed might also be different. Now, let's take the first case. When the object is kept at the center of curvature. Now here I am taking a concave mirror. When the object is kept at center of curvature, the image will also be formed at the center of curvature itself. And one of the properties, if you remember, of this image formed is that the image is going to be of the same size. If the object is 5 centimeter, the image is also going to be 5 centimeter itself. So the formula for magnification becomes M, which stands for magnification, is equal to Hi divided by H naught. Hi is nothing but the height of the image. H naught is nothing but the height of the object. And when you find this ratio, if the object is of the same size as well as the image, if the object as well as the image are of the same size, then when you find the ratio, people, you will get it as 1. So when you find out the ratio, for example, if the object size is 5 centimeter, image is also going to be 5 centimeter if the object is kept at center of curvature. Then when you divide it, what will you get? You'll get as 1. So when magnification is 1, that means that image and object both are of the same size. The next condition is when the object and the image size is a little different. In this case especially, image is much more bigger than the object. Now in this situation, people, look at this. When the object is kept between the focus and the pole, the image is found behind the mirror. And I told you that the image is going to be much more bigger than the object as well. It is basically an enlarged image, not a diminished one, but an enlarged virtual image. Now guys, once again, in this case, if you find the ratio, the value that you're going to get is always going to be greater than 1. For example, let's say that the height of the image is 10 centimeter and the height of the object is 5 centimeter. So magnification is what? Height of the image divided by the height of the object. Height of the image is 10, height of the object is 5. So what will you get? 2, and 2 is greater than 1. So guys, when the height of the image is greater than height of the object, that means magnification is going to be greater than 1. Or if you ever see magnification value is greater than 1, then you can say that that image is a magnified image. So if you ever see this value m is greater than 1, you can directly come to the conclusion that that image is nothing but a magnified image. Simple. Examples of that, you can talk about your makeup mirrors, you can talk about your shaving mirrors, you can talk about the dentist, the mirrors that is used by dentists to check what is happening inside your mouth. All of that will give you an enlarged image, and magnification of all of those would be greater than 1. Alright, the next situation is when the image is smaller than the object. Like in this case, when the object is kept beyond C or between C and infinity. So the image in this case is much more smaller than the object. In this case, guys, when you find out the ratio hi by h naught, you are going to get a value which is less than 1. So if ever, people, you see a value, the value of magnification being less than 1, you can directly come to the conclusion that the image is what? A diminished image. As simple as that. And that, my friends, is what I had to teach. That's all. This is your magnification. And that is the same case with convex mirror. In convex mirror, no matter where you keep it, you will always get magnification as less than 1 because the image is always diminished. Examples, your mirrors that is there, the parking mirrors and all that, around the corners and all that they keep, all of that magnification is going to be less than 1. Alright, so yeah guys, and if you talk about magnification, if let's say that in a particular question height of the object and height of the image is not given, but rather the object distance and image distance is given, u and v are given. So if that is the case, then the formula becomes m is equal to minus v by u, where v is nothing but the image distance, u is nothing but the object distance. This is nothing but the image distance, and u is nothing but the object distance. All right, so minus of image distance divided by object distance will be equal to hi by h naught, that is height of the image divided by the height of the object, which is equal to magnification. So all of these, this is one single equation that you must remember when you're solving your numericals, if in case they ever ask you to find out what is the magnification of the image. All right. So yeah, people, if you enjoyed the session, do not forget to like, and I will ask you some questions right now. We'll get into the quiz questions. But before we get into the quiz question, guys, this is what I would like to share. If you guys want to enroll into the pro exclusive courses and learn more about lenses as well as electricity and many other topics just like those ones, you can enroll into Vedantu's pro courses, which not only guarantee you that we'll give you 100% knowledge of every subject, but also if you want to score 100% marks, then why not? Vedantu is here for you guys. We are giving you the promise, guys, that your scores will definitely improve. With Vedantu's improvement promise, there is no doubt that your scores are going to improve without a question. And yes, guys, unlimited number of live sessions, super amazing sessions, which are going to be a lot more fun, and more importantly, it will give you an opportunity to understand what are your strengths and weaknesses and compete with your friends and colleagues and become better every single day. With this people, you also have the interactive replay sessions, which not only gives you the replay of what happened in the past, but also gives you an opportunity to take the quizzes while you're watching the replay and check out the leaderboards as well. You can download all of the premium content, every single thing that you see, even this dot would be downloadable. You can download it as a PDF and you can refer to it whenever you want. And every session will have a set of two teachers, the master teacher and the class teacher, to ensure that every doubt of yours is answered without any prejudice. All of the doubts would be cleared. Unlimited doubt solving with real-time doubt solving is what we are giving you. With that, tests and assignments are obviously given, and these tests and assignments are also like beautiful questions which will definitely help you better in your board exam preparations. And with this, guys, lots and lots of micro courses, your KVBY preparations, NTSC preparations, Olympiad preparations, you would have a quest, you would have stress relief sessions, entrepreneurship sessions. You have pretty much a holistic development happening here at Vedantu. It is not just focused on your syllabus, but it's focused on preparing you better for life, not just for your exams. All right, that is what Vedantu is giving you guys. So how do you enroll? What are you supposed to do? It's quite simple. Let me just quickly take you through this. So this was the video that came out last time, which is sign convention and mirror formula. You can check out the video and see for yourself if you have any doubts or not. So what you do is, guys, click on show more. Click on register to Vedantu Pro. Click on this link, guys. This link is all you need to enroll into any course at Vedantu. So what you have to do, guys, click on this change, go to whatever grade, whatever syllabus you are in, whatever syllabus you follow in school, click on that. And here, guys, you can check out there are 3 different plans or 3 different courses offered at Vedantu. Now again, guys, all these courses have different features in them. Vedantu Lite has everything that you need. You have live interactive sessions, test series and assignments, you have doubt solving inside the class, but there is no doubt solving outside the class. That option you have in Classic. You have doubt solving outside the class as well. In Vedantu Pro Plus, you have not only doubt solving outside the class, but you will also have someone called as a personal mentor. Now the personal mentor is that one person who is going to be with you from the start until the end. He will ensure that you're on the right track. He will ensure that you are getting the right motivation. You are on, you're able to understand every topic. He'll make sure that you are, getting all sorts of one-to-one sessions to help you clear every doubt of yours. Now the price of these 3 would be different. Now as a teacher, I would suggest you to go with the 1-month program and then decide for yourself what do you want to do next. So 1-month program of Vedantu Lite is 2,340 rupees and the year-long program is 29,699 rupees. Now guys, you must be wondering, sir, 2,000 rupees is a lot of money, but think about it, guys. In the 2,400 rupees, 400 rupees, you are getting all 6 subjects: physics, chemistry, bio, math, English, social science, all six subjects you're getting. So that means that out of this, if you think about how much you're paying per session, or per subject, that's basically about 400 rupees per month. That is the same amount of money that you pay outside also. And more importantly, guys, with all of these, you're also getting KVPO preparations, NTSC preparations. For all of that, you don't have to pay extra also. Everything is for free included in that. And the again year-long program is 29,699 rupees. These are the amazing teachers who are going to be teaching you: Ncert sir, Abhishek sir, Surabhi ma'am, Kritika ma'am, Harsh sir, Nikhil sir, all of these amazing teachers. With this, you can also check out all of your timetables, when the timings are going to be, and you can also check out the past year's results that we have produced, not last year because exams did not happen, the year before that. And you can also check out the students' testimonies as well. So all of these things, you can check it out over here. Every detail that you need would be here on this website itself. All right, so yeah guys, once you enroll into the course, you can check out all of the details. Everything would be there on your dashboard, right? So yeah guys, with that said, let's solve some questions now. I am urging you guys to please make sure that you attempt every question. More importantly, you guys know that now CBSE has changed the pattern also. So these quizzes, these MCQ type questions will be the lifesavers. All right. So make sure you attempt every quiz question. Try it for yourself. Tell yourself if it's A, B, C or D and be honest. All right. So first question is this, guys. Which type of mirror magnifies a close-up image like a makeup mirror? Would it be a concave mirror, convex mirror, a plane mirror, or you can't see it at all? Come on guys, go for it. Which type of mirror magnifies a close-up image? Again, I will give you 5 seconds. If you need more time, pause the video, take your own time, answer the question, but be honest. All right, 5, 4, 3, 2, 1. The answer is concave, guys, because concave mirror is the only mirror that can give you a magnified image. Convex, remember Vedantu's Ved, that is, it is always virtual, erect and diminished. Plane mirror is always going to give you a virtual image which is of the same size and it's also erect in nature. All right, next one. If the magnification of a body size is 1 meter, of a body size of 1 meter is 2, what is the size of the image? So the magnification is given as 2, m is given as 2. The object's the height of the object is given as 1 centimeter or 1 meter, sorry. You're asked to find out what is the size of the image. Simple question, guys. Again, options are 1 meter, 2 meter, 3 meter or 4 meter. Try it out for yourself. Do not copy the answers. Let me just, okay, there's no space, so let me do it over here itself. So yeah guys, the formula is m is equal to hi by h naught. M is given as 2. Height of the image is what you're asked to find out. Height of the object is 1. So height of the image becomes 2 into 1, which is what? 2 meters. So the answer is 2 meters. That's a simple question. Bacha. Alright guys, next one. How much does a flat, you mean a plane mirror, magnify an image? By how much does a plane mirror magnify an image? 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x. All the PUBG players. 6x, 8x. Alright, in 5, 4, 3, 2, 1, it is 1x, people, because a plane mirror will always give you a same sized image where the magnification would be equal to 1. Simple. Next one. A coin is placed 10 centimeter in front of a concave mirror. The mirror produces a real image that has a diameter of 4 times that of the coin. What is the image distance? Let me repeat the question. A coin is placed 10 centimeter in front of a concave mirror. The mirror produces a real image that has diameter 4 times that of the coin. So magnification is given as 4 times of it. All right. What is the image distance is the question. Now again guys, options are 40 centimeter in front of the mirror, 40 centimeter behind the mirror, 20 centimeter in front of the mirror, or 20 centimeter behind the mirror is the question. So guys, let me write down the given data. So m is given as 4 because you're getting a 4 times bigger image. So it's 4. The coin is placed 10 centimeter in front of the concave mirror. So object distance is given as minus 10 centimeter in front of it. No, remember the sign convention, it'll be in front of it. So the formula is, guys, m is equal to minus v by u. This is the formula. So m is given as 4 minus v divided by minus 10 is what you have. Minus gets cancelled. So what is v equal to? V is equal to 40 centimeter. Since it is plus, that means that the image is formed behind the mirror, not in front of it, but behind the mirror. So the answer should be, okay, sorry guys, I think we did a mistake, calculation mistake. Wait, what? Alright. Guys, no. Look at this. The problem is that they took u as minus 10 over here, and they wrote u as direct 10 centimeter. So it should be minus 10. So that minus gets cancelled. So it's going to be plus 4, right? So plus means it's going to be a virtual image because again it's going to be from behind the mirror. Unfortunately, it's a tiny error. There is a small typo mistake. So kindly ignore it, guys. It should be minus 10. Alright, it should be minus 40 centimeter. Minus 10 over there. So minus gets cancelled. So it should be plus 4. No, because it's going to be minus. So this is 4. Okay, wait. 1 second. Oh, yes. I'm sorry, guys. I'm sorry. The mirror produces a real image. My God, real image means yes. Real images are always inverted in nature, guys. I'm so sorry. It's my fault. So real images are always inverted in nature. So I have to take it as -4 because again sign convention. Real images are always inverted, so it'll be -4. So yeah, then it'll be yes, it'll be -40. That makes it in front of the mirror. I'm so sorry, guys. My fault. Human dad, we make mistakes. Chill. So anyways, it'll be in front of the mirror. I did read the question so carefully. Anyways, so guys, this is your homework question as well. Do your homework questions. Let me know what is the answer in the comment section. The question is, a concave mirror produces 3 times magnified or enlarged real image of an object placed at 10 centimeter in front of it. Where is the image located? Let me know what is the answer in the comment section. Now again, don't make the same mistake that I just did. It's a real image, so take it as -3. It's 3 times magnification, so it's going to be -3, and object is going to be -10 centimeter. Find out what is the answer. Alright, so yeah, people, that's all for today then. And yes, you can also enroll into the pro exclusive courses like I mentioned before. This pro exclusive course is for you guys to ensure that you are getting again a particular topic. So we're going to be focusing on only on that particular topic, and we'll ensure that you are able to understand it 100%. Alright, so again, if you enroll into the pro subscription courses, you can also enroll into this one for free. Alright, so that link is right there. The link is given in the description. Thanks a lot for joining. Do not forget to like, share, subscribe. I'll catch you guys in the next session. Until the next time we meet, have a great day ahead, and see you all soon. Take care, guys. Bye bye. See you all.